Let's talk about Cramer's rule. Cramer's rule was developed by Gabriel Cramer as a way of solving systems of linear equations using determinants. There's a picture of him. The solution to the system of equations is this. Oh my goodness, that looks beastly, but it's actually not as bad as it looks. The denominator is the coefficient matrix. So you've got the coefficient matrix for the system of equations, no big deal there. And the numerator of x sub I is the coefficient matrix with the ith column replaced by b. In other words, if we're dealing with something of the form ax equals b. So in this case, for example, x1, it's just the coefficient matrix on the top with the first column replaced by b1, b2. x2 is just the coefficient matrix on the top with the second column replaced by b1, b2, because it's x2. If the denominator is 0, the system has no solution. Here's an example. Solve this system of equations using Cramer's rule. X plus y equals 2, 2x plus 4y equals negative 2. Let's see. So on the bottom, we have the coefficients. That's the determinant of the coefficient matrix, 1, 1, 2, 4. Same thing here. And then this is just going to be the coefficient matrix, except in this case, we're going to replace the first column with 2, negative 2, and in this case, we're going to replace the second column with 2, negative 2. So notice what we end up with. This is just going to be, so the numerator is the same as the denominator, except we've replaced the first column with 2, negative 2, and here we've replaced the second column with 2, negative 2. Otherwise, the numerator and denominator are the same. So here's what we get. We evaluate these determinants. This first determinant on the top, well, on the bottom you get 4 minus 2. Same thing here, same thing here. On the top, you're going to get 8 minus negative 2. Here, you're going to get negative 2 minus 4. So in other words, we get x equals 10 over 2, which is 5, and y equals negative 6 over 2, which is negative 3. Solve this system of equations using Cramer's rule. X plus y plus z equals 6, 2x minus y plus z equals 3, 2y minus z equals 1. So we know what the denominator is going to be. It's just the determinant of the coefficient matrix. 1, 1, 1, 2, negative 1, 1, and 0, 2, negative 1. Numerator is going to be the same, except we're going to replace the first, kind of missed it there, or the second, or the third column with 6, 3, 1. So we end up with x equals 5 over 5, which is 1, y equals 10 over 5, which is 2, and z equals 15 over 5, which is 3. From Cramer's rule, we can obtain this formula for the inverse of an n by n matrix A. A inverse is 1 over the determinant of A times this. This is the matrix of the cofactors. We've talked about that before. It's called the adjugate of A, and we denote it by, uncreatively, ADJ of A, adjugate of A. To be honest, this formula for A inverse, and really Cramer's rule, they have theoretical value rather than practical value. It's not like we'd routinely use Cramer's rule to find the solution to a system of equations, but yeah, it has some theoretical value.